Section 7.5, the inscribed angles. So let's take a look at our lesson objectives here. And we start by finding the measure of an inscribed angle. And to find the measure of an angle formed by a tangent and a chord, our first definition here is to define what an inscribed angle is. So an inscribed angle is an angle whose vertex is on the circle. The intercepted arc is an arc whose endpoints are also the endpoints of an inscribed angle. So if we take a look at the diagram here on the right, we have angle C right here, and we can actually just call this angle ACB if we wanted to, but in this case angle C. So angle C, the vertex of this angle is right here on the circle. The legs of the angle, or the endpoints of this angle, happen to intersect my arc, and this arc is called AB, arc AB, and they intersect. So this is my intersected arc, arc AB, and my inscribed angle is angle C. And that's the main way to actually find or identify graphically what a inscribed angle is. Let's actually take a look at our first theorem, Theorem 713, the inscribed angle theorem, which states that the measure of an inscribed angle is half the measure of its intersected arc. So let's take a look at what that actually means. In here we have angle B, and angle B is my inscribed angle. Its endpoints intersect arc AC. Here's arc AC. So we can make, based on the theorem 713, we can say that the measurement of angle B is equals to 1/2 the measurement of arc AC. And that's what the theorem actually states, and we can actually use this to solve certain problems. And we're going to take a look at some examples right now. So let's get to it. All right. Number 1, part A, using the inscribed angle theorem, find the values of both A and B. So let's take a look at the diagram here on the right. So the first thing that we're going to do is solve for A first. Notice that A is over here, is in degrees, is an arc. Also, that arc is known as PT, from P to T. So that arc is PT. So I can actually make one relationship right off the bat using the inscribed angle theorem, and that is that the measurement of angle PQT equals 1/2 the measurement of the arc PT. And we can say that that is by the inscribed angle theorem. Inscribed angle theorem. All right. We can substitute now, because we know that the angle of PQT over here is 60. So we can say 60 equals 1/2 A. And that is by substitution. So to solve for A here, we have 60 equals 1/2 A. To get A by itself, we multiply both sides by 2. So the 1/2 goes away, and we multiply 60 by 2, we get to 120. So we have 120 equals A, and that's 120 degrees, and that is by solving for A. Okay, for B, we also use inscribed angle theorem, but we actually go by stating that the measurement of angle PRS equals 1/2 the measurement of arc PS. So the measurement of PRS, right? PRS equals 1/2 PS. PS, right over here, right? So we have that, and we can say that is true because of the inscribed angle theorem. Inscribed angle theorem. Okay? Then now we can say that B itself, B equals 1/2, and we have the measurement of arc PT plus the measurement of arc TS, and we can actually say that because of the arc addition postulate, and the arc addition postulate just says that if I have an arc that contains two or more arcs, the sum of those arcs give me the total of the bigger arc. So in this case, we have arc PS, right? PS right here, but within PS, we have PT right here, and we have TS as well right there. So now that we have that, we can say that this equals 1/2. Let me actually write a better 1/2 than that. 1/2 120 plus 30, and that is by using substitution. And then we just go ahead and simplify this, and we get that B equals 1/2 150, which gives me 75, and B is an angle, so that needs to be in degrees, and that is because we simplified. So we get this by simplifying. And that's how we get both A and B. Now, take a look at the diagram one more time. Part B is yours to solve. As soon as I finish reading it, make sure you pause the video, give it a shot, and afterwards, see if you get the same answer that I do. Good luck. All right. So the first thing that we actually take a look is that we can use the inscribed angle theorem here. In this case, we can just say that the measurement of angle PQR equals, actually, the measurement of angle, pardon me, the measurement of angle PQR, and this actually is not yet, but we can actually use that in a little bit. PQR equals the measurement of angle PQT plus the measurement of angle TQR, and this is by the angle addition postulate. Oh, let me actually make the better T than that. Postulate. Postulate. Much better. Postulate. Because we see that PQR right here, to get PQR, PQR has is made out of two angles, right? We have PQT right here, PQT that measures 60, and then we have TQR rather, TQR, T right here, QR, which we don't know yet, but we can actually get that. All right, now we know using something else here that the measurement of angle, or keep saying angles, we're talking about arcs now. The measurement of arc RT equals the measurement of arc RS plus the measurement of arc TS, and this we can actually use the arc addition postulate. All right. Then we can actually say that arc RS is 60 plus 30, and we do this by substitution. That gives me that the measurement of arc RT equals 90. Then we can say that the measurement of angle TQR equals 1/2 the measurement of RT, arc RT, and that is because of the inscribed angle theorem. Inscribed angle theorem. Let me shift this a little bit right there. And then we can say that the measurement of angle TQR equals 1/2. We found that RT happens to be 90, which gives me 45 degrees, and that is what TQR is, 45 degrees. But then we say that the measurement of angle PQR is 60 plus that 45 we just found, and that gives me 105 degrees, and that is my answer. Hopefully that's the same answer you got. All right, moving on to the next thing is some corollaries based on the inscribed angle theorem, and we have 3 of those. In case you don't remember what a corollary is a statement that if you have a theorem that we have proven to be true, corollaries are statements that derive from the theorem, that if the theorem is true, so are those corollaries. And those are that 2 inscribed angles that intercept the same arc are congruent. An angle inscribed in a semicircle is a right angle, right? Because we know that a semicircle measures 180 degrees, and by the inscribed angle theorem, that inscribed angle would be half of that arc, and since half of 180 happens to be 90, well then that makes that angle a right angle. Okay, then the last one is the opposite angles of a quadrilateral inscribed in a circle are supplementary. The opposite angles of a quadrilateral inscribed in a circle are supplementary. Okay, now let's take a look at a couple of examples here. And we have part A. It says find the measure of the number angles. So let's take a look at angle 1 is the only angle here that is numbered right here. So it is an inscribed angle. And the angle where it actually, that is intercepted, not the angle, the arc intercepted happens to be a semicircle. And a semicircle happens to measure 180 degrees. So by the inscribed angle theorem, we can actually say, and I'm just going to write this statement that I have here. So it is the measurement of angle 1 is inscribed in a semicircle I'm going to say a semicircle measures 180 degrees. That's just by definition of a semicircle. And then we can say that the measure of angle 1 equals 1/2 of 180, which gives me 90 degrees. And there we have that one. That's for number 1. For number 2, we're looking for angle 2. Okay, so notice one thing here. This actually applies to corollary number 1, because if you take a look at angle 2 is an inscribed angle, and it actually intersects this angle right here. Okay, but then again, we look across this arc and we have this 38-degree angle over here that is also inscribed, and that means that this 38-degree angle here and angle number 2, they intersect the same arc, which means by the corollary that both are congruent. So we can now say that angle 2 and the 38-degree angle intercept the same arc. So by corollary, by corollary 1, the angles are congruent. So angle 2, so the measurement of angle 2 is also 38 degrees. And that's that one. Okay? Well, let's take a look at what's next. Part B. Part B is for you to do. It has its own diagram here. So you know the drill by now, hopefully. As soon as I finish reading it, pause the video, give it a shot, and then see if you get the same answer I do. So we start. For the diagram at the right, find the measure of each numbered angle. Have fun. All right, let's take a look at this one. So the first thing that we can see is that angles 1 and 3, both are inscribed angles. Actually, all 4 angles are inscribed. So we can say that angle 1 and 3, well, are inscribed, but they are intercepting arcs of the same, actually they're both intercepting semicircles. Angle 1 is intercepting this semicircle, and angle 3 is intercepting the other half of the circle, or the other semicircle right here. So that means that each of these are half of 180 degrees. So we can say that the measurement of angle 1 is congruent to the measurement of angle 3, which equals then 1/2 180, which gives me 90 degrees. All right? So that's one thing that we have. Then we can actually say the measurement of angle 4. The measurement angle 4 is inscribed over here, and it actually intersects this arc right here. But this arc right here is composed of two smaller arcs. One measures 60, the other measures 80. I can use the inscribed angle theorem to find this. So it goes like this. The measurement of angle 4 equals 1/2 the sum of those two. So we get 60 plus 80, which gives me 1/2 times 140, which tells me that that is 70 degrees. All right. Now, we have three angles. So we know is notice that the figure inscribed into the circle here is a quadrilateral, and a quadrilateral, all four angles should add to 360. So you could actually just add the three angles that we have right now, and we can find angle 2 very quickly. But I'm going to use the same approach as I used earlier. So we can say, for instance, that we have angle 2 right here. Opens up and it intersects this arc right here, right? So we don't know what that arc is, but we know the other two, and we know that the whole circle is 360. So we can just say that the measurement of angle 2, equals 1/2 times the whole circle, 360 minus 140. That gives me 1/2 times 220, which equals 110 degrees. And that's how we find our four missing angles here. All right, let's take a look here. Theorem 714 states the measure of an angle formed by a tangent and a chord is half the measure of the intercepted arc. So what that means, we can actually say, and the formula I'm about to write here applies to both of these circles. So we would actually say angle C, which is the angle that we're talking about, angle C here and angle C down here, okay? The relationship is that the measurement of angle C, equals 1/2 the measurement of the intersected arc, which is the measurement of arc BDC, like so. All right. So now let's take a look at a couple of examples. Okay, using Theorem 714. In the diagram here on the right, Kj is tangent to the circle at point J. Find the values of x and y. So let's take a look at how this would actually work. So let's take a look here. We can say that x, right here, that's angle right here, x. So we say that x equals 1/2 the measurement of arc JL, right there. And that is because of the Theorem 714. Theorem 714. So we can now say that this equals the measurement of angle Q by the inscribed angle theorem. And we can say that this equals 35, and that is because of substitution. All right, so we have x. X equals 1/2 the measurement of the arc JL, right? JL right here. So that is what the theorem 714 says, that x is 1/2 the arc JL. All right? Okay, 1/2. But now we know we have angle Q, well, that happens to be 35, right? Angle Q is 35 is given to us. So doubling 35, right, would give me the measurement of this arc, right? So 35 and 35 is 70, right? It's 70, but then to get this, angle X is half of 70, which will give us back the 35, which is where this 35 came from. So in essence, this angle right here is the same thing as angle Q. That's where that 35 came from. All right? To get Y, using here theorem 714, says that Y equals 1/2 the measurement of arc QJ. And that is by theorem 714. Then we can say this equals 1/2 the measurement of QL, that's RQL by the way, plus, actually this will be a minus by the way, minus the measurement of ArcJL, and that is also by the arc addition postulate. Okay, then we go ahead and substitute. So we have 1/2 of 180 minus 70. That is by substitution. That will give me that Y equals 1/2 times 110 equals 55, and that Y, since this Y is an angle, is 55 degrees, and this is by simplifying. All right, so we know that QL, arc QL right here, arc QL is a semicircle, right? QL is a semicircle, so that's where we get the 180, right? And JL, well, JL, we got it from earlier in the problem for when we were doing calculations for X. if we actually JL, well, JL, we can say that it is twice the inscribed angle. So this is 35 plus 35 is 70. So we want to find out what the arc is, and we just take the difference to find that arc. So we just say 180 minus 70 by substitution, and the rest is just some calculations that we can do. All right. Now part B is still using the same exact diagram. So in this case, it's asking you to describe two ways to find the measurement of angle KJK using Theorem 714. Pause the video and give this one a shot. All right, so we have two ways to do this particular problem. So we have one, and I'm just going to say one way is to say that the measurement of angle QJK equals the measurement of angle LJK plus the measurement of angle QJL. And this is actually really by using the angle addition postulate. And way number two is really using the Theorem 714. So we have that the measure of angle QJK equals 1/2 the measurement of arc QLJ. Then this equals 1/2 times 70 plus 180 equals 125 degrees. And that is our lesson for inscribed angles. If you have any questions, please make sure to send me an email or communicate through Teams, and I'll be more than happy to answer any questions. You can actually Canvas, you can also contact me. So I'll see you next time, guys. Thanks.